For today's video we're going to take a look at a 1964 IBM 214 portable dictation machine. The intro sequence you've just been watching will have been recorded sometime in the future, but for now let's have a look at the machine as it was when it first arrived. It's a little bit smaller than a sheet of A4 paper in size. If I press this button here, the panel flips open, revealing the controls. There's a lever here that you can move to listen or on, and up to record. If you pull this down here, it'll rewind the tape a bit. There's a volume knob here, and there's a battery level indicator over here. The tape playhead can be moved to any position on the tape or belt using this lever here. There are a couple of buttons on the top. These leave an indentation in this sheet of paper beneath. The top button would be to indicate the position of a new dictation, and the bottom one could be used to highlight a correction the secretary needed to make. I had a pack of these paper sheets that came with the machine. There's a lever over here to fine-tune the alignment of the head should that be required. If we move round to the front, there are a couple of pegs where you can attach a strap so you could hang it round your shoulder. And it was a portable machine after all. And then there's a little door here that contains the microphone. Looking inside the hatch that the microphone came out of, on the right hand side you've got an auxiliary power input, and then the mic socket itself, and then you've got a dictate conference switch. If it's in conference mode, it increases the sensitivity of the microphone. Next to that you've got a switch so you can either listen through the built-in speaker or through the microphone that doubles up as a small speaker. And finally you've got an earphone socket. On the other end of the machine, if you press this button here, the lid hinges open so you can replace the belt. I'll release the catch so we can flip this lid all the way back. And you can see some of the insides. The belt itself is a sheet of plastic with a magnetic coating applied. It slides onto the rollers like that, and then when the case is closed, the belt is tensioned. The drive motor is here, and there's a drive belt here that goes to a pulley that then transfers the drive to the recording belt. This drive belt here is a bit sloppy at the moment, so we'll have to have a look at that because it's slipping when it tries to run. But there's another problem with the machine, so we'll have a look at that in a second. Okay, I've got the machine hooked up to a power supply. If I move the lever here into the on or listen position, nothing will happen until you press the button on the side of the microphone. So I'll press that, and all you get is white noise. And that white noise doesn't change even if you move the volume part. So there's obviously a problem on the amplifier somewhere, so the next thing to do is to strip the machine apart and see if we can track down what the fault is. The first thing to do is to get the lever and volume knob off. So the lever is held on with a little grub screw, so we'll see if we can get that out. Okay, that should be loosened, and with a bit of luck that'll come off. And then the volume knob is just a friction fit, but it's quite tight, so we'll get a bit of card down so we don't scratch the plastic face here, and then just gently prise it off, and there she goes. Next I should be able to release this whole section here. There's a little bit more down here to look at in a minute, and it looks like there's another screw just in the side here, so I'll just rotate this so I can see. And there's a spring that's attached to this one, so I'll have to remember that goes there. And that's that plate off. The circuit board itself is held in by 4 screws. 2 of them are accessed through the hatch where the microphone is kept, and the other 2 are in the top here. So that's one of those. I've already removed the 2 from the microphone compartment. and that's the other one. So the next thing to do is have a look and see which wires I need to disconnect to actually remove the circuit board. Okay, I've removed all but one of the wires that needs to come off to get the board out, but for the last one I've got to get the board partly out just to get that wire off. So just see if we can extricate it. Looks like it's going to take a bit of a wriggle. Right, I think I can now get at the last wire that needs to come off. Maybe. There she blows. Well, this is interesting. I can't believe this is all that's wrong with it, but there is a loose wire here that's broken off its solder pad, and that's completely loose, so I shall solder that up in a second. Well, that's soldered up. I'll put the machine back together and see if that one joint was all it was. So a quick update, having put the machine back together after soldering that one broken wire, it's still got all the white noise, but it does sort of slightly work now. I'll demonstrate.
No sense for typing. 22nd year.
So apart from sorting out the white noise, which could well just be capacitors that need replacing, and getting a belt that doesn't slip, with a bit of luck everything will work fine, and then we can listen to what's on the recording belt. The original drive belt on the IBM had gone hard and stretched. It seemed to be about 2mm too long, and I figured I wouldn't be able to go out and buy a new one, so I made my own replacement. I bought the cheapest turntable or record player drive belt that I could find, and cut a section out of it 2mm shorter than the length of the original belt. I then put down a little bit of double-sided tape with the backing left on. This was just to use as a non-stick surface. Superglued the ends of the belt section I'd cut and held it together exactly lined up, and then pressed it down with another bit of double-sided tape with the backing left on the end of my finger, and that kept it flat as the glue dried. And the end result is a working drive belt that you can't even see the join on. So, another quick update. I've got the board out again, and I'd taken the first two capacitors out to check them, and their values were more or less as they should have been, and the ESR reading was okay as well. And so when I was putting those two back in, I noticed the leg of this foil capacitor here. Now if I grab the back of that capacitor and give it a little jiggle, if I can find it with my finger, you can see that leg is loose, which would be plenty enough to cause the problem. So I'll resolder that one, and I'll also have a real thorough check of the board to see if there's any more loose components. And then we'll see, we'll probably put it back together and see if it works. Okay, another quick update on the IBM. Having soldered the loose leg of the foil capacitor, it was this one here, I put it all back together again and tested it. And it might have been a bit better, but there was still loads of white noise. So I took the rest of the capacitors out and checked their values, and some of them were out by quite a bit, sort of 50% away from their stated value. So I'm going to now replace all, or at least most of the capacitors on the board, and see how it is after that. Okay, capacitor number 1 to come out. I've already scribbled on the other side of the board the polarity of all the capacitors, so I don't need to pay too much attention at the moment to which way they come out. So let's have a look. This might be difficult to do with the camera, but we'll see. See how we get on. Okay, that's one leg loose. And the other one. And we have 10 microfarad, 6 volts. Okay, so here we have the original capacitor that came out of the board and the modern replacement, which is teeny tiny by comparison. Okay, we'll get the first leg soldered, then check the position. That's one. Check it for position. That should do the trick. Second leg soldered. Looking good, just double check that. Yeah, that's good enough. And snip the ends off if I can find my side cutters, which are somewhere over here. And I'll keep these because they're always handy for making bridge wires for other things, when you've got broken tracks on circuit boards and stuff like that. Okay, and now for the last of the capacitors that I'm changing for the moment. Let's see if we can get this one out. That's one leg, that's the other leg, that was pretty easy. Okay, and let's get the new one soldered in. That's one leg, that's the other leg. Good. That will do for the moment. And looking at the board from the other side, you can see all the new capacitors because they're blue, whereas the old ones were a sort of, well, silvery colour. One of the capacitors here, I couldn't get an axial in that value, so I used a radial capacitor, but that doesn't really matter, it's just the leg pattern that's different. There is actually one more capacitor buried under this bundle of wires here. I've left the old one in for the moment. If I think I need to change that one, I'll have to come up with some sort of plan, because that's going to be quite difficult to get out from there. So after replacing most of the capacitors, I reassembled the unit and gave it another test, and unfortunately the white noise was still there. By this stage I didn't really think the capacitors were the problem, but for completeness I dug out the one under the bundle of wires here and replaced that, and no surprise it didn't make any difference. My usual approach to things like this is solution by substitution. I'll gradually work round the board replacing things until the fault goes away, and therefore I found the faulty thing. And usually this serves me really well and I'll get to the solution really quickly, but in this occasion it really wasn't helping. Anyway, next I turned my attention to the transistors. We've got 4 of them here. And I took them out and tested them, and the one that was over here gave some really odd readings. It didn't seem to be working correctly. So I tried to find a replacement for it. But unfortunately I couldn't find any match to the markings on it. I knew that it was a germanium PNP transistor, but that's about as far as it went. Anyway, at this point I turned to a fellow YouTuber for help, CuriousMarc. He also owns one of these machines, and he and his friends do some fantastic restorations of old equipment. They've done teletype machines, mechanical calculators. They're even currently working on a clock from a Soyuz spacecraft, which is pretty brilliant. I'll put a link to his channel in the description because it's well worth a look. Anyway, Mark also couldn't identify the transistor, but he did make some really good suggestions to find a replacement. And the machine now works without all the white noise. So I think the next thing to do is a demonstration. To demonstrate the machine, I've got it hooked up to a bench power supply because I haven't actually got the batteries for it at the moment. If I pop the panel open so we can get to the controls, put it into the listen position, and then press the button on the microphone and put it into the lock position, it'll play the recording.
Suitable connection points will be provided transfer of material from one silo to another, for the topping up of partially filled silos, etc. Full stop. Material transfer from silo to tanker or other container will utilize the same procedure. Full stop.
And there we have an original dictation from when the machine was in use. So the next thing to do is to try recording onto it. I'll move the recording head into a position where I know there's some blank space on the tape, and we'll try doing a little recording. So we'll move the switch here up into the record position, and then we'll give it a try. You'll notice in the little window down here there's a black and yellow moving band. That's actually on the edge of the drive mechanism for the recording belt, so you get a visual indication that the machine is working. Anyway, let's see what this recording sounds like. I'll move it back into the play position and move the tape head back a bit and see what we've got. You'll notice in the little window down here there's a black and yellow moving band. That's actually on the edge of the drive mechanism for the recording belt, so you get a visual indication that the machine is working. Anyway, let's see what this recording sounds like. And you've got the reverse lever that allows you to reverse the belt a bit. So you get a visual indication that the machine is working. Anyway, let's see what this recording sounds like. Let's see what this recording sounds like. Let's see what this recording sounds like. Like that. So I think the next thing to do is to see how the machine gets on with a bit of music recording. Obviously it was only designed as a voice recorder, so it's not expected to do great with music, but we'll give it a try anyway. So I'll put it into record mode, and I'll start it recording, and then I'll hit play, and we'll see what we get. Okay, and let's see what that sounds like. So I'll put it back into the listen position, move the tape head back a bit, and put it onto play and see what it sounds like. Yep, and unsurprisingly that's not particularly hi-fi sound. You may have noticed what sounds like hiss on some of these recordings. That's actually the sound of the drive mechanism, and in particular the motor. It's a very sort of hissy sounding motor. If I put it onto play with the volume right down, and you can hear that hissing sound, that's not coming through the speaker at all. If I stall out the motor in a second, you'll hear the sound goes away. So yeah, that's some fake hiss. It's nothing like the white noise we had before, which was really quite loud. Anyway, that's about all for this video. If you've enjoyed watching, feel free to like the video and subscribe to the channel. There'll be more vintage stuff and repairs coming soon. So, thanks for watching, and I'll see you in a future video.